Okay, we're going to be working on a relative motion problem. We have a boat. It's moving toward the east, which we will call the plus x-axis, at 7 knots relative to the water. The wind relative to the boat, that is what the boat sees, is moving at 14 knots at an angle of 60 degrees. And our question is, what is the wind relative to the water? Let's place our x and y axes and make sure we understand what they are. And of course, plus x direction is in the horizontal motion. The plus y direction is in the vertical motion relative to the paper. Now, our relative motion equation, we have to consider two frames. The water is one frame, and the boat is another frame of reference. So first question I want to ask you is, why is the wind not a frame of reference? Why can't I say the boat and the wind, or the wind and the water? Well, the simple answer is I could, but the fact is that what we're after is to find out what the wind's velocity is relative to the boat. And so the wind is our unknown. So let's consider one dimension just for a minute here to try to get our minds wrapped around how to think about relative motion. We consider the wind as the particle here, this particle P, okay? And its velocity relative to the boat we'll denote as VAB for velocity of air with respect to the boat. And the velocity of boat with respect to the wind we'll denote, of course, as V sub BW. That is the velocity of boat with respect to the water. Okay. Now, what I want to know is, what is the velocity of the wind with respect to, or the velocity of the air with respect to the water? Now let's look at this in one dimension. If here I have the velocity of wind, or the velocity of air moving with respect to the boat at a certain velocity, and the boat moving at a certain velocity, how do you think they will add to give the velocity of the air with respect to the water? Take a moment and try to think your way through it. So we have that the velocity of the air with respect to the water will be equal to the velocity of the boat with respect to the water plus the velocity of the air with respect to the boat. And this holds whether we're looking at one dimension or we're looking at vector quantities. We can set the equations up in one dimension, but then go to the vector form almost immediately. Can you see, if everything is in the x direction, can you see how we get to this equation? Now let's put everything in terms of unit vectors. First of all, what is the velocity of the boat with respect to the water in terms of unit vectors? It's moving in the positive x direction. Of course, that's going to be 7I hat knots. Now, what is the velocity of the air with respect to the boat in terms of unit vectors? Go ahead, take a minute, write down what you think it's going to be. Of course, that's going to be minus 14 cosine 60 I hat plus 14 sine 60 j hat. And we can write it as minus 7 I hat plus 12.1 j hat. Now, what is the combined, or the sum of those two vectors? Well, we're left with 12.1 j hat knots as being our velocity of the air with respect to the water. So it's basically moving in the vertical y, positive y direction. Now, if to add a little more difficulty to the problem, What if you ask the question, what is the max speed assuming no drag by the water? That is, what is the maximum speed of the boat? I'll leave that for you to ponder, and we'll call this the end of the problem.